Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
All right. So in this problem, so we have a spring attached on the ground, and we have a block. And when the block is reached, when the block reaches the spring, they are attached. Okay. Uh, okay. So the mass of the block is m equal to 0.25 kilograms, and the spring constant k equal to 2.5 Newton per centimeter, or 250 newtons per meter. Okay, and so we know that when the spring, so the maximum the maximum compressed distance of the spring is h equal 0.12 meters. So for part A, we want to find out the gravitational force, the work done by the gravitational force in this process. So the work done by the gravitational force is simply mgh. Okay, so this is m, and the g is the gravitational constant, and here's the h. So you can find out the value is 0.29 joules. This is joules. Okay, and for part B, we want to find out the work done by the spring force. So when the block reaches the lowest place right here, so the work done by the spring, Ws, will be equal to half k times h squared. But in this case, this is a negative because the force is opposite to the displacement of the block. So this is negative. So k is here 250, and h is here. So you can find out the value is negative 1.8 joules. So now if you compare these two results, you see that the work done by the spring is actually smaller. I mean, the magnitude of this work is actually larger than the magnitude of the gravitational force. So the residue comes from the initial kinetic energy of this block. So to find out this initial kinetic energy, we can use E K, the kinetic energy, initial kinetic energy, plus Wg, which is the work done by the gravitational force, equal to the work, so not equal to, and plus, sorry, and plus the work done by the spring equal to 0. So we can solve for the Ek equal 1.51 joules. So we can solve for the initial velocity Vi equal to 3.47 meter per second. Okay. And for part D, so say that if the speed at impact is doubled, what is the maximum compression of the spring? So let's say Vi in this case equal to 2 Vi. So this is the new initial velocity, which is doubled. So equal to 6.94 meter per second. So again, we can utilize this relation. So Ws equal negative Ek minus Wg. And because we have a new compression at this time, so Ws, this is a prime, this is primed, this is also primed. We have negative half k h primed squared equal to negative half m Vi prime squared minus this h prime, okay, minus mg h prime. Okay, so in this equation, we can see that we already know k, we know m, and we know g. So the only unknown variable is this h prime. You can solve for this h prime by just solve this equation. So h prime, you will see that it equal to 0.23 meters.